Good afternoon. Good afternoon. I hope you're having a wonderful Thursday. My name is Alex Cooper. If I haven't had you in an on-ground class in the past, or if I've had you in one of our virtual classes, welcome, welcome. Let me introduce myself. My name is Alex Cooper. I teach the computer classes at the Columbia County Library in Evans, the library in Harlem, Utah Creek Library, now the Grovetown Library, yay. So, of course, we're all staying home, staying safe and everything, and we're doing all our classes virtually. So, welcome to our YouTube channel. Definitely make sure that you do like and subscribe and all that kind of good stuff. You do need to be logged in to be able to post anything into the comments, so definitely log into YouTube for that. So today our project class is a little bit something different, okay? So we have a Raspberry Pi class that we do some fun stuff, make LEDs light up and all kinds of stuff like that. But we wanted to start talking about maybe doing some other projects and stuff, because when we were on ground and everything, of course we're doing all our virtual classes now, had such a big outpour of people coming to do that, wanted to add stuff. So we've got some projects we can work on. So hence this month's class, Raspberry Pi Computing Projects with Alex Live. And that's me. So what we're going to be doing today is we're going to be working on our GPIO music box. It's actually from the Raspberry Pi website. I believe I can do it. We'll have to see, won't we? So it's directly from their website. And in a minute, I'll show you that we've got if you paid attention and went to the other Raspberry Pi classes, you'll see that I got a box of all kinds of components and goodies and stuff. And I thought about working on these projects by myself, but I thought, well, we can make a class out of that and we can kind of learn together. Okay. So a big one always is please post any questions into the chat. Like I said, you do need to be logged in to be able to do that. And how can I help? Okay. Have you worked on a Raspberry Pi project and had some problems? Here's a good place to ask me questions about it and, you know, see if I can help in any way. I'll be posting the links into the classes, the stuff that we're going to be covering. And I do know there's a little bit of delay, so I would just if I ask a question, I'll kind of pause. Hey, Mac, welcome, welcome. Glad you're here. So let's talk about the classes we've done recently or this week. So Tuesday, we did cutting the cable. I think I've already have a good many views of that class. So it's a great class. I call that one of our biggest classes that we've had on ground. We had 50 people sign up for that class, and then we had to do an extra class, and 25 people came to that class because it was such a huge thing. That was about 2 years ago we did that. So we've been doing this class more and more, so definitely feel free to share that with friends or family. Got new stuff on there about Peacock service and of course Pluto TV. And yesterday morning we talked about Chess 101. These videos are all still up and available, so definitely go to the YouTube channel, which are on right now. And you can view the other videos as well. Chess 101's fun class, had some new stuff to share on there, and something talking about blitz chess. So it added a little bit of extra pizzazz to our normal chess classes. We also did our library resources and apps yesterday. And this kind of connects up with our cord cutting because we also talked about Acorn TV and also the IndieFlix TV that you can get a subscription to free through the library. So this morning we did our YouTube 101 class. So that was a fantastic class. Hope you come back and enjoy that and share that with friends or family too that want to get involved. And here we are at a Raspberry Pi class. Here's a list of our classes that we have for the rest of the month. So this class today ends our classes for this week. So next week we'll be doing Word, Excel, PowerPoint, and then the end of the month we'll be doing our photography series, and we have some new classes too, like we've updated some of our PowerPoint classes where we've moved around. If you've been in our photo editing class, now it's going to include layers. So it's a full Photoshop like using GIMP photo editing and layers class. We'll use free software so you can follow along as well. And I'll also post the examples so you can follow along too. We moved our virtual scrapbooking to a new class, photo photography printing and virtual scrapbooking. So come out for that. And also, especially if you're interested in YouTube and the rest of the stuff, we're doing again for our second month, our new class, creating videos and editing basics. We'll have 2 more projects for next week. So come join me for that. Little side note, our libraries are open with limited services and hours. Curbside holds pickup is available. You don't forget, you can go to gchrl.org for details or call the library with questions Monday through Friday, 10 a.m. to 5 p.m. Don't forget to like us on Facebook and subscribe to our YouTube channel. We need to get 100 subscribers so we can get our own address, our own name address. but you can right now search YouTube for GCHRL videos and our channel will pop right up. So let's go back to our main part here. So this is kind of neat, and I will tell you this is an experiment, all right? I have had it where this worked out great, and my extra cameras in video capture worked great, and then I've had it where the whole thing crashed. So if it does crash on me, I'll try to come back on, and we'll start back from there. It may create a new video, so just be aware of that. I may just label it as part 2 or something, but we'll try our best. And when we try to do bleeding edge stuff, sometimes it does not work out. So let's go ahead and let's get started here. Let's talk about what project we're going to work on. So this was a fun project I wanted to start incorporating into a new Raspberry Pi class, and now we're kind of at home, staying safe, of course. And it lists it as a music box, even though it's kind of more of a let's make it play sounds box. Or, you know, there used to be a thing where you had like a little thing and it made all these kind of different noises and you press the buttons. And I'm not sure they still make that. But you can get soundboards, apps and stuff like that. And they're like pre-made sounds. Just kind of funny, silly stuff. So basically making one of those out of a Raspberry Pi is kind of what we're going to be doing. Okay. So it calls it a music box, but I think it's more like a sound machine. Okay, but this is the official Raspberry Pi site. It's projects.raspberrypi.org, and just search for the project GPIO Music Box. Okay, so let's go ahead and let's look at a little video.
Today, you're going to wire buttons to your Raspberry Pi and use Python to make a sound machine. Project, you will need a Raspberry Pi, a breadboard, some buttons, and some male-to-male and male-to-female jumper cables. A Raspberry Pi has 26 GPIO pins. GPIO stands for General Purpose Input-Output. These pins allow you to send and receive on-off signals to and from electronic components like LEDs, motors, and buttons. Each pin has a number, and there are additional pins that provide 3.3 volts, 5 volts and ground connections. A pin diagram or labeler like this one helps you to know which pin is which. Buttons give you control over a circuit and let you send signals to a computer, like the keys on your keyboard. Before wiring your circuit, switch off your Raspberry Pi. Place one of your buttons onto your breadboard like this. Make sure you push the legs as far down into the holes as you can. Next, connect a ground pin on the Raspberry Pi to the negative rail on the breadboard using a male to female jumper wire. Then, connect the negative rail to the button with a male to male jumper wire. Now connect the other leg of your button to GPIO pin 17. Using another male-to-female jumper wire. You've now created an electrical circuit. It has power and a pathway to conduct the electric current. In your circuit, the current flows from the Raspberry Pi's GPIO pin through the circuit to the ground pin. Your button acts as a switch that can break the circuit. When the switch is open, no current can flow. When the switch is closed, the current flows from negative to positive through the completed circuit. Which way does the current flow in your circuit? Early scientists believed that current flowed from positive to negative. They called this conventional current. We now know that current actually flows in the opposite direction, from negative to positive. But we still use the term conventional current, which can be confusing when you're new to electronics. What we can agree on is that electronics is all about controlling electric current to make it do something useful. That's the hardware complete. Now for the software. We're going to use a Python programming environment, or IDE. Create a new project by clicking New. Set up your button by typing from GPIO 0 import button. Then create a variable, btn equals button, open parentheses, 17, close parentheses. Next, define a function that will print the word hello. Def hello, open parentheses, close parentheses, colon. Print, open parentheses, quote, hello, quote, close parentheses. And finally, create a trigger that calls the function. btn dot when underscore pressed equals hello, and save it as music box. When you run your program, the message hello should appear each time the button is pressed. Now let's add some sound. Create a directory called music box in your home directory and save the sound files you want to use in here.
So let's go ahead and let's start working on the first part of our project here. And let's again, we have another quick little video to show. So that's kind of our goal, is to make it just a little sound machine is what we're trying to do. Okay, so like I said, hopefully this is going to work out okay. And I'll actually have two inputs happening at the same time. If my software does crash, I will come back and try to finish the project. If we do have any issues, I may call it video part 2. Okay? So knock on wood, here we go. All right, so we've got our Raspberry Pi on, and I'm actually going to start. So here now you can see hello. Look, and I can do like a bird, all kinds of neat stuff. Okay, so we can see if our so give me a minute as I try to work with the video capture. Okay, we'll play around with that in a second. Let's go ahead and let's look at our project stuff, okay? Okay, so we'll work on hooking up our buttons and then kind of flipping back and forth as well, okay? Okay, so here we are. We're reading about our project. So used to, I had like a little box of goodies, and now I have a new box of goodies. This is actually from Free I believe it's called. This is a Free Rfid Starter Kit is what it's called. I could post a link into the thing, but if you just search, if I drop it, and I can actually show the back of it too. If you just search for the RFID kit, it's $40 and it has a whole bunch of really neat things on it. And this comes with it too, with its own breadboard, but I'm going to use the one I previously had because everything's already in here all nice. So we have all kinds of electronic goodies on there. Maybe the other project we'll do is we'll get our buzzer to work in the future too. So let's look and see, and it's even got a game controller stick on there as well, motors, servos, an RFID tag reader. So again, this is trying to basically be like a starter program to basically show that we can do many different projects with our Raspberry Pi. We don't have to just do you know, the basic ones, the LEDs, which a lot of folks have already done that and want to do a little bit more with Python. So there you go right there. So we have our resistors. This is a unique one because in class we actually have a nice little, and I'm blanking on what it's called, a nice little cover that goes on here and tells us what the GPIO pins are on each little pin here. But the way this setup is you have a breadboard and you actually set it up so it actually tells you what the GPIO pins are, and you actually take a ribbon, plug it here, plug it in there, and then you can do jumper stuff like that. Now, I personally haven't done that before, so I'm going to do it the way that I do know how to get it to work pretty easily. So basically, we'll be kind of flipping back and forth, checking our GPIO pins to make sure, because I have a nice diagram to go with this here. So the interesting thing about this class and us doing this is I usually tell students this is me at my most mad scientist, okay? So you'll see me going, oh, I got to get this over here, got to get that over here. So we have our male-to-male wires. We have male-to-female. This also have a breadboard that can carry power. This actually has the RFID in there. I'm hoping that that'll be a future project, okay? Maybe to turn something on and off. This is supposed to be the, my brain's blanking on what it is. But anyway, I have a full set on their website. Tells you what everything is. This tells about distance and movement. I forget what that sensor is called. But anyway, what we want to do is we want to get some buttons, don't we? Okay. And it also has a nice analog joystick in here too, so you could actually create or use that to control stuff too. And like a keypad thing. So it's a lot of neat things, LCD going on here. So we want to get our buttons, okay? So I'm going to go ahead and I want to move this out of the way. And hopefully you can see everything pretty clearly. I hope you're enjoying class so far, because this is a unique experience here. Alright, so we actually have our, and I'll move this for now. We start our coding, we'll need our keyboard. So we've got our breadboard here. I'm going to go ahead and take everything off. This is our setup when we did our LEDs the last time. These are LEDs. We got our button. Now, what we're actually going to do is we're actually going to plug in 4 buttons is what our goal is. So let's go ahead and get our 4 buttons. So we have our Raspberry Pi, number 1. Number 2, we have our breadboard. Number 4 is we need 4 buttons. Let's pour it out and put it back in. Alright, so there's 1, 2, 3, here's 4, we got switches too, all kinds of fun stuff. Now, the neat part about the buttons is I can actually have little hats for the buttons, and yellow, so they'll have different colors, okay? Now this project, we could expand it, which I'm not sure if we'll do that today. Depends on how much time we have. We could expand it with an LED that turns on when we hit a button too. Okay, so we've got our buttons. Now we need our male to female wires. Okay, so how many of those do we need? We need a male to female jumper. It says we need 5. There's male to female. There's 1, there's 2, 3, 4, and 5. And it says we need 4 male to male. So here's 2 male to male. These are some short ones, aren't they? Okay, let's see if I can get a long one out of there. Cable ties are your friends until they're not. Come on. Usually in our work I actually have some kind of music playing, but because of YouTube I can't just play music. So if you're at home and playing along, you may want to get some music playing. Okay. There we go. What is that? It's 4. Yeah, so there just be 4. Yeah. Well, one thing I do believe in is that basically you try the setup of some kind of project, even if you're cooking or something like a recipe, and you try it their way first, and then you can go back and change it to something else later. Okay, so we got our wires, we got our buttons, we got a breadboard, speakers or headphones, and I actually have this Bluetooth speaker I'm going to connect into, but just with the headphone jack. We're not going to try to program the Bluetooth out or anything like that. Okay, so now that we have that, and our Raspberry Pi actually has the latest software on it. It's not called Raspbian anymore. It's actually called just Raspberry OS. So it's Raspberry OS, so don't let that throw you in any way. This is the one that I recommend because it has all the software built in and everything. Just realize you do need like a 16 gig memory card would probably be best. Okay, so let's go ahead. Let's go right ahead. If you do need a printout version, if you are maybe watching this, and I just blocked the screen, sorry. So if you are watching this for some reason to be able to do it in a class for someone, this website does allow you to have a printer-friendly version of this. Okay. So let's go right ahead. We're just moving right along here. Alright, you'll need some sample songs for this project. There are lots of sound files on Raspbian, but it can be difficult to play them using Python. However, you can convert the sounds into different file formats that you can use in Python more easily. First, in Home Directory, create a directory called GPIO Music Box. You will use this new directory to store all your files in your project. Okay. Well, I wanted to go ahead and do the wiring first. Okay, so I'm actually going to skip this part and we will come back. We will skip this part for now. There we go. I want to go ahead and do the physical stuff first. So, let's talk about our GPIO pins. Okay, so if I go to, and I will post, I'll be able to post this in the chat. Give me 1 second. This will be our handout from our normal Raspberry Pi class. This is the handout from our normal Raspberry Pi class. It'll go into what a GPIO is. Means general input output. So this is basically it, and we can zoom in, and it actually is a schematic here showing us what the GPIO pins are. Okay, so I'm actually going to use that as a reference for myself. Okay, so we have our general input output pins. Talks about which they are. The main thing to know is that some of them are ground and some of them are GP, which is when we do our Python code. That number will matter. Some of them give out 3 volts of power and some give out 5 volts. Okay. There's another chart right here explaining that. Now, the big thing about this is to basically have it turned this way. So if I hold up, oh, that's funny. I thought you could do those two things together. That's funny. So basically the best thing to do is hold your USB facing down, and if you're holding it next to that screen, you'll see that it actually equals this right here. Okay, so there's the big circle that's up there, and I'll use my mouse to point to it. That's funny. There's the big circle, which means that's where the screw goes in right there, and that kind of goes along telling you what it is. Okay. I know someone's at home going, that should be in a case. It's okay right now. It should be in a case. It's okay. So let's talk about using buttons with our Raspberry Pi. A button is one of the simplest input components you can wire. To Raspberry Pi, it's a non-polarized component, which means you can place it in a circuit either way round and it will work, meaning it's not positive or negative. Excuse me, it doesn't flow one way like the LED or something. And see, look, it's even showing this way up, but it's kind of best to think about the USB being down. Okay. There are various types of buttons. They can, for example, have 2 or 4 legs. The 2-leg versions are mostly used with flying wire to connect to the control device. Buttons with 4 legs are generally mounted on a PCB or a breadboard. The diagrams below show how a wire 2-leg or 4-leg button, and I do want to show a big thing about the breadboard. When we talk about our buttons, how circuits flow, we need to close a circuit. Here's our LED right here. This is what I was talking about, the buttons, it doesn't matter which way, some things like LEDs. So here's our positive. Now she said that we're not 100% sure exactly which way electricity is flowing right now. There's some theories going on. But for this example, we'll make it go this way because that will make sense more to our LED example. Connects this way, connects up to our LED diode right there. And we also have our fuse or our resistor right here. Thank you, resistor right here. And then we have our button that closes the circuit, but it has to go back to the ground. So anything that goes this way, we have to have a ground on the other side. Okay. Buttons are kind of on or off. Okay. Breadboards, no need to solder. on a breadboard. The big thing is to kind of look at it as it being the way it's set up. So when we hold a breadboard, we do need to realize that here's the rails. Some project will use the rails. Some projects will use just the different rows. Most of my projects I've done with LEDs and buttons, we're actually just using the what they call bars on there, okay? And I actually consider this the river because nothing connects in between. So we can put an LED here, one leg, the other leg here, and then connect them up going out that way, okay? So we've got our breadboard. We've learned about our breadboard. We're hooking up a wire, okay, a button. Hooking up more than one button, okay. That's using the rail system. This is kind of the normal way we've done it. Here's our rail system. Good thing about the rail system is it connects to the ground, and then we only have to have one connection going back to the Raspberry Pi, okay. So I think our example is going to have us do that. Okay, so we've placed the 4 breadboards. Wire each button a different numbered GPIO pin. You can choose your pins you like. Okay, you will need to remember the numbers. Okay, so let's go ahead and let's do that now. So we've got our breadboard, and let's put our buttons on there. Now with these buttons, it's actually this side that matters. So we're going to make one the positive and one the negative. But if you wanted to do one button for one thing, you can have it on the other side too. The teeth, basically, we kind of situate it over the river is what I call it. And then we kind of press down hard. We should hear a nice little snap noise. And that one kind of slid in there. I didn't hear a snap, but you'll see that it's very much on the bottom. And the teeth are inside the holes there, and then we hear the nice clicky noise. Clicky noise, clicky noise. Okay. There's our first one, and we'll make him red. How about that? So we put our little top on. Button 2. I'm going to try to kind of uniform these a little bit here. Four spaces open. Make sure you're not bending the teeth. I've had some students that aren't putting it in fully and they press hard and it bends it. Just unbend it. Maybe with a pair of tweezers or something. Very satisfying button clicking going on here. Alright. Very nice. Okay, now remember we actually have our system going on here where we just need it to be on the same side on this side here. So I'm actually going to do, this will actually be my first project doing it because I usually do them separately to the ground. We're connecting 4 things at once. So we're actually going to use our rail system. Okay. So I'll put our first one here. Okay. And I told you we're learning together. Learning together. Let's see a short one here. And we'll do just like the example. We'll make the top. And as long as you're on the same row as the tooth here, okay, should be good. So we're going to make this just like our example. We're going to make this our connect into our GPIO. And we're going to use this one here to make it ground with our rail. about that? Ooh, wire sticking in the air. Okay. You don't have to cram stuff in here. You just kind of have to press it pretty good. And then we'll have it connect to our rail, negative. Okay. And our button. Do that with our male, female. Okay, male to male. Female. Alright. A question I get asked is, does the colors matter? Colors do not matter. It's up to you what the colors are. You watch TV or movie or something and they go, cut the red wire. Well, you can make the color cord anything you want. Alright, so let's look at what we have. Let's check it. Make sure the rails are set up properly. So negative, this will be negative once I plug it in. Negative, negative, negative. And then we have our now make sure it's on the same row, making sure it's on the same row. Same row. Okay, good. Okay, now, so these four things are what we're actually going to connect to our board. Okay. Now, I was hoping that they would show an example of what numbers they wanted, so I would be the same. Just give me 1 second here. Let's see. Hold on. Don't look, don't look. Okay, so they've got it on 4/17. Okay, so that's kind of my goal here. I'm going to make a little note for myself. Okay, so we want to use 4/17 just when we do our code later. It'll be all uniform with them in 10. Okay. Let's go back. Now, let's bring over our sorry, I need to make that jump around like that. And bring up our notes. Okay, now, oh, it's completely blocking it, isn't it? Okay, so okay, we can deal with the windows, can't we? Okay, so let's go back to our notes here. Okay, so we actually want, this is ground, so it's got to go to ground. Now, I'm going to go ahead, I'm actually going to do this sideways because it wants to sit like that just because of where I have the cords and stuff, but it'll be okay. Okay, so we want our ground. Where's our first ground on here? Where's ground? Okay, so our first ground is top left, right. So it's on the right third row. So 1, 2, 3. Right third row. Okay, now we want this one to be 4, so where is GPIO 4? GP4 is the fourth one on the left. Fourth one on the left. Alright, the next one is 17. 17 is 1, 2, 3, 4, 5, 6. So that's 4, 5, 6. 6. And then 27 is 1, 2, 3, 4, 5, 6, 7. Okay, so it's right next to it. On the left. And then our last button says it should be 10, and 10 is, wow, we have 10 all the way down there, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 10 is 10. Okay, so that's 7. So 1, 2, 4, 5, 6, 7, 8, 9, 10. So 10. Okay. And there, we have our buttons all lined up in a row now, don't we? Okay, so go ahead and let's go back. All right, now let's hopefully we can get our end. So I may disappear here for a minute. If something does happen, I'll restart again, but YouTube may start a new video, okay? So I'm going to try to bring in I'm still here. I know the screen.